Applied research that we are doing, some of the learnings that we are having, not only for research trials, but also for some work that we do on farmer fields. To give a bit of a background I am a cropping system specialist. Two of the main topics that I work is in nutrient dynamics and also water use efficiency. And I work in different crops, and one of them is sorghum. We do some on-farm trials, but in general, I look at the resource use efficiency, how much, yield or biomass we can get based on the resources that we have for the plant. So sunlight, water, and nutrients in general, and how we can put all the crop management together to maximize that efficiency in general. In a crop or in the system, we do work across Nebraska, so those are different places where we have been having some experiments across the state. I am based in North Platte, so the West Central area is kind of where I do most of it, but there are some collaborations and trials that we do across the state. We work at the national level, and actually I will show a bit some results from a sorghum research of a multi-state, but I work with soybean and corn in two multi-state groups where we kind of share applied research and do some extension work there. And then international level, I do some work also, mostly in subtropical and tropical environments, which is different from what we do here. So the idea is to complement and learn with some collaboration internationally. It's still in nutrient dynamics and water use. So for today, I have some learnings that we have from UNL TAPS, so Testing Ag Performance Solutions, and that was run for, I think, 6-7 years. Excuse me. I took the information, I kind of, from the reports, I started building some learnings, what we can learn from all those trials and the decisions that those teams were making. There are some agronomic trials. Those are mainly on research stations, some things that we did for the last 2 years and some trials last year that we're going to repeat. There are some multi-state efforts and some also on-farm research that we did, and some thoughts and summaries from all the learnings that we have so far. And hopefully, we can have a discussion or some thoughts from your side, because the idea is that anything that we do in applied research, is something that could be useful potentially for farmers or that is of your interest. So we are here to help and to build up on more information that will help you. So some of the learning from TAPS. So this is, on that side is all the dryland hybrids that were chosen by the different teams, and then they irrigated here. The interesting thing there that we found across the years that, 34% of that selection was across like 3 hybrids. And interesting, the same from dryland and irrigated fields. And that was something very interesting to me. Usually, if you look at other crops, there is a bit more turnover on those genetics, and usually there are some distinct between, irrigated and dryland because of the performance of those genetics. So it seems that there is something that probably is not as fast, the translation between the genetics improvements and what we see on the choices that farmers they do. Some of the other decisions, and these are only decisions, so there is no treatments, but that's what people decide to do. In terms of the nitrogen rates, obviously in irrigated it was higher than in the dryland, so about 100 pounds for the dryland and 150 pounds for irrigated. That was kind of what they chose to do. 63% of the participants decide to do a pre-plan dryland and 50% in irrigated. So it seems that in the dryland, most people were choosing to put more pre-plan. It makes sense because if there is no water, putting it later on is more complicated to incorporate that nitrogen. And then for population, in dryland, the average was about 55,000, 56,000, and then in irrigated, it was almost 90,000. And we are going to show some differences there. Okay. So, first of all, we look across all the environments and all the irrigation decisions. So here is the grain yield, and on the bottom is the available water that is quantified in this case. It's all the rainfall that you get from January up to the beginning of the season plus the irrigation. And you can see that, increase the yield, but then there is a point where there is no more increase. So it seems that more than 21 inches in total, there was no more increase. So what does it tell us? Well, first, if we know a bit how much is the rainfall that we have, obviously it depends on each field what capacity you have to store that water in the soil, but still it gives you a good idea that if you are getting more water, how much water you can budget for your irrigation if you're in irrigated fields, and to not over-irrigate if you get to those 21 inches. So it seems that there is no more necessary improvement, and if you overdo, start to drop a bit. And those are results from the 5 years that we did. In this case, it's nitrogen. And there were some questions about nitrogen, and I think there are a couple of things here. So across those years and the locations were North Platte, and I think there were a couple in Grant. So it's the same location. But the increase with the nitrogen fertilization was not much. And if we look here at the number, is 0.18, so 0.2 bushels per each pound of additional nitrogen. That means that you need at least 5 pounds of nitrogen to increase a bushel in this case. But why is that? If you look at the no nitrogen, which is that part, and you look at these points here, so you can see how many bushels you could get, at least in these fields, without any nitrogen. So you can see that there is a range. The lowest one was probably 85, and the highest one was 160, which is probably pretty high. And that was in fields, from the taps. But this is an important part, because I think there was a question early on about saving nitrogen, and I think the best way to know in your field what's the nitrogen is to leave on a strip without fertilizer and then check your yield. So you know how many bushels you get from that soil, and then start calculating back. Obviously, it's not going to be nice. You're going to probably, if it's not a good field, you're going to see some yellow there, but you can live for 1 year with that and then learn from that for the next years. So learning how much is going to come from the soil, it will help you to plant also later on. And then if you can see, the efficiency here is not very, very much, because 5 pounds of nitrogen to get the bushel is a lot. So that's because you are in a soil that already is providing a lot of nitrogen. Now, the white points here is the dryland. No response, basically. And they went from, the decisions were from 0 to more than 150. But in the 0, you can produce 100 bushel in that field. So probably there was a lot of remaining nitrogen there. Obviously, you can do soil tests and test that, but still, having a strip without nitrogen will help you to understand how many bushels you get if you want to do it in your field. Okay, other learning is seeding rate. On the upper side, the blue ones is mostly the irrigated, or the ones that have more than 12 inches. So the white ones is the dryland, and this is all from taps. So in the dryland, not much response, from a range of probably 35 to up to 90,000 plants in those 5 years of competition. So there was a variability in yield, but not necessarily related to that plant population. In the case of irrigated, well, there was an increase, but I would say, above 70, probably there is not much of increase on the yield there. And we are going to see some tests there as well. So there is some room on the seeding rate to play. There are other aspects, you want to reduce tillers, or you want to maybe it dry faster. So there are different things to consider, not only the seeding rate itself, but it seems that there is a point where, there is not much increase. And for the dryland especially, there is more room to play without losing yield. Okay, now more plants produce more heads? Yes. And that seems, so we count in some, there were 2 years that we did different, so the different populations in the taps, we count the heads, and as you increase the population, there is more heads. But that doesn't mean that it's more yield always. And if you look here, as you increase the heads, there is an increase in yield, but it gets to a point that there is no more. And if you look at in that equation that we had, I think the maximum got to 90,000 heads, but that's about here, so it's almost about the end. But if you look at the cloud, more than 70 heads in 1,000 acre, so it doesn't increase much. I did the math, and that's about 40 heads in 10 feet. So that's kind of, if you're in 30 inches. So if you do 10 feet and you count 40 heads there, you're in about 70,000 heads. 70 heads in 1,000 acre, which is kind of about this part here, where the maximum yield starts to appear there. Okay, what else we can do? So when we had this information, I presented in one field day, and then we had some conversations also with Dr. Bean and other producers as well. And what else we can do? And one of the things that caught the attention is, well, 180 bushel was the maximum. Can we do more in irrigated, of course? Well, there were some thoughts that came about planting time, row spacing, plant population a bit, and nutrient management. But the interesting thing when we look at the planting time, so this is the temperature, soil temperature, and this is the average of 5 years, and this is in the area of North Platte. So it seems that an average soil temperature can get, in May 5th, can get to 55, 57, where are the lowest temperature that probably you will plant some of that sorghum. So, but usually the sorghum is planted late in May or early June. And if we look at the planting dates from tabs here, I think the earliest was May 18th. But then the other ones were late May and some in early June. So we thought, well, maybe we put some planting days early and maybe we gain some more bushels, especially in irrigated. And we were questioning those things. So then is when we came with some of those experiments, and I'll show some results now. So, early planting field. So 1 year we did in Grant, 2 dates, and that was May 20th, and then the second one was in June 17th. The second year we tried to get a bit earlier, so May 13th, and the last one we did it in June 1st. And as you can see, there is a drop, probably not much of a drop if you planted mostly in May. And if you get to mid-June, it's already dropping a bit more. And this is not only, it's the average of 4 hybrids that we had with different duration and also the replicas. So there is a pretty strong background with, behind that. So what I did all the combination. Well, if you are planting in general in May 20th and then you move to, or you're in June and you move to May 20, well, there you're going to gain a lot. Probably if you move, mid-May to late May, it's not much what you get, but still you get some boost there. And in an average, if you're moving, from let's say June to mid-late May, it's about 40 bushels that potentially in these experiments could change. So obviously it depends on the fields, and this is all irrigated. But still, there is a big change there, and we are going to compare those changes with other practices that we tested. Okay, hybrid selection. In this case, the hybrid selection was for the cycle length. So shorter, middle, and long hybrids, and there were 2 years, so the 2 colors are the 2 years. So there was the 2024 was a bit lower yield in general. 2025 was a bit higher, but as you can see that in this case, this length of the hybrid was pretty much the same on the other one, but kind of was so too short or too long, it didn't work there. And that difference, when you look at the selection of the hybrid and you say, well, I pick a short one or a long one, well, I did all the combinations, kind of the average could be 14 bushels. So still probably the planting day was giving more of a difference than the selection of the hybrid. But as you can see, the choice of the hybrid for the cycle length could change assuming that you are doing a full season, that's the system. No, there are different systems as well, and different things to consider there. Okay, row spacing. And this one was a big surprise for me. I was betting that the 15 inches was going to yield more, and actually in the field it looks better. It closed the row faster. It looks very nice, but then when we went to harvest, it didn't necessarily yield more. This is 1 year experiment. We need to repeat. I'll show some on farm that was a bit different. But yeah, we did some 30 versus 15 inches. Behind each bar, there are different populations as well, but we didn't have much of a difference of the population in some cases. So, but yeah, not much difference in these cases, irrigated and dryland, which it was a bit of a surprise. There are some things that we are thinking there. Some of the soils are a bit high pH. Potentially there is something there, but we're not sure why this. This is 1 year. There are other research that show that there is a bit more increase in the 15 inches. Still, it's not only on the increase of the yield, it's what are the benefits that could get you if that's what you're looking for. For example, weed control or other things that you may look for that 15 inches. But in this case, we didn't have as much difference as planting early, for example, or selecting the right cycle. Sorry, I didn't see you. Yeah. In the yields of the row spacing, no, we didn't see much. No, it was again, it was a bit frustrating for me because I was betting that 15 was going to do the difference, but I didn't see it clear. There was variability. It wasn't very clear, and the averages did not show. But I think there is something else going on there that we need to figure out. But yeah, that was a big surprise, and I didn't see something clear with the planting day. Usually, I don't know, for example, in soybean, if you go later, the narrow row will get you a boost on the yield. If you are in early planting, not necessary, and in those cases, well, in soybean, it's more about the white mold or other things. But in this case, I couldn't see that trend, especially. But there is one experiment that they did in Grant with different hybrids, and I think it was 2019, and it was 1 year still, I think. But they say that in that was also, yeah, that was kind of an extension, and it was 75% of the cases there was an increase in yield, and there was a 25% where there was not. So there were some yes and no, but it was more an increase. So I'm a bit curious about what's going to look this year and see if we can figure out what's going on there. Still, general improvements when you go to the field, you see it close the rows faster, that for sure, and it didn't look like bad, so it looked very good in the field. Okay, seeding rate. We have some, in irrigated, we tested kind of a bit higher in combination with those row spacing to see if we can push that yield more than 180, and those are averages. We had some 180 and some almost 190, but in specific plots, but the averages across the hybrids and the row spacing was a bit lower. And 85 and 100 did not make a difference to go there. So we didn't find any difference there on the irrigated. And on the dry land, well, going to 35 probably was the lowest, but still it didn't move much, 97 to 99 in the dry land field. So there were not many changes in the case of the seeding rate in comparison with selecting the hybrid and also the planting date that we saw before. All right, I'll show some multi-state efforts, and this is more of a combination of an apply and also more of a base research, I would say. So the objective is to quantify, the growing degree days, to be able to predict more the stages of the crop across the different regions, and understanding if the hybrids have a different behavior across the region. So this is a project that is led by Dr. Ignacio Ciampiti, and Federico Gomez was the person who was coordinating, and I asked them to provide a couple of slides so we have sort of a summary where we are at. And anyway, so those are the red points are the different places where we had experiments for 2 years. So 18 experiments, 2 planting dates, and some of the results of the planting dates are the ones that I showed before, and 3 hybrids to look at the differences in those growing degree days. So in general, there were different numbers of leaves that you could produce in the different hybrids. Of course, the shorter and the longer. But they find that there is also a change when you plant early or when you plant later. So that means that there is a sort of a photoperiod effect a bit that could affect that number of leaves that you can get. And that's what they want to do later on, trying to rule out how much is that effect in the different regions, especially to predicting, how early is going to be the flowering and so forth. All right, some on-farm, and this is something that we should do more, and I think it's very interesting, and we have been doing some plant population, some row spacing. We're doing again this year, I think. Hope, Tracy, right? And probably learning something else. But yeah, the best way is sometimes to test it in your field. Today there is a lot of technology and ways to do it. The university has the on-farm research network program. So this information is all published in that program. So the idea is we get together, it's something that you're interested, that you want to see in your field, if there is a difference. In this case was seeding rate. So there were 35, 50, and 65. This was a dryland field. And in this case, we did strips in 2 different places of the field. It could be more replicate if you want. You can do more strips, you can do less. Today, if you look at the yield map, for each of those strips, you have thousands of points of yield. So if there is a difference, it needs to show up there in those strips. In this case, not a difference in the yield, at least not significant. It seems that, there was a bit more on the 35, but not significant. So that was about 130 bushels, and it was the same across the board. It seems that there was a tiny bit moisture on the 35, but not significant necessary. And well, then there is a sort of a marginal net return. That's the comparison of the price with the bushels, but it was not significant. So in this case, the farmer actually say, well, probably next year I will drop a bit the population because I see that there is not much of a room there. And as we saw in the tabs, in the dryland, there was not much of a deal with the population. So if it's something about population in the dryland, maybe it has to be more with the harvest, quality that you may get, or something else. But probably you don't want to risk it to the 35, but something between the 35 and 50 still will get you the yield. Okay, row spacing. We did some row spacing on farm, so in comparison with the other results were in the research station. This is on farmer field. So we compare the 15 inches, again the 30 inches, and here are the yields. So it was a difference in the yield. It seems a good difference, but it was not significant because there was a lot of variability. And when we look at the different reps, it was kind of up and down. It was not very clear across all the replicates or all the side-by-side comparisons. So that's why, statistically it was not, but the 15 inches in the final number, it raised the yield in this on-farm. So we still need to learn a bit more why such a variability we have when we compare that, which is not the same that we have with others. And there were some comments about that the 30 inches had more full heads, and then the 15 inches was more consistent or full loads across the header. That was some observations from the field. All right, and I'll show some other on-farm that we do, but this is not grain sorghum. This is forage sorghum. And I asked before, I said I'll do something with forage, but I don't know if people will be interested, but I'll show some results there. This was a different project. This is in the Sandhills. And there was some interest to understand a bit more if there is some summer forage varieties. So the systems are different. They do a winter crop for hay in general. They go out the winter crop and they do a summer crop also for hay. So this and it's very sandy soils, low fertility, low organic matter in the majority of the cases. So we did some field days there to see different varieties and mixes and also understand a bit some of the information. So I'll share some results. So that's what it looked like. We crossed the whole field with those varieties, and then we clipped some forage across the field to understand a bit the variability. And in this case, it was a drill that has 3 boxes, so we put one variety in each boxes. We turn around and then we change, we vacuum and we change the varieties and we kept going. And this is one of the examples of what we did in those fields. So I don't want you to look at all the numbers, but you can look at it in the presentation if you are interested. But one of the key things that we found there, so those soils were low organic matter. For example, potassium was very low, like average 40 ppm, which 150 ppm, 120, 150 ppm is the threshold to start fertilizing with potassium, for example. So the interesting thing here, most of the ranchers there, they were focusing on nitrogen fertilizer. They put phosphorus, and they were putting some sulfur. Nothing of potassium. And if you can see the forage, especially you are clipping the whole plant, so it's not the grain, it's the whole plant. So the requirements or the amount of nitrogen and potassium that they have in the biomass is almost the same. So there is a high demand of potassium in forage crops that usually is overlooked, especially in places where you have low potassium requirements. So that was the main thing that we found there. But then we look at the different varieties, and you can see. So there are some sorghum, there are some some Sudan grass, there is some mixes, there is some millet, and ranchers were interested about the millet and the difference with other ones as well. This one that say pace setter, that's the photoperiod sensitive sorghum that they were mentioning today. That was very interesting. At least one of the ranchers that he does rotational grazing, he was very happy about that one. The other ones that were more doing hay, it was still a good performance. But that was something interesting there. So when we look at the nutrient requirement per ton produced, and the averages are on the bottom, and then with the colors, you can see the green is kind of the lowest, and then the red will be the highest requirement. And some of the interesting comparisons was that, well, millet require less nitrogen per ton produced than most of the sorghums in general. But then when you look at, I'm shading there, but when you look at the potassium, if you look, the most red is the millet. So those fields were in low potassium level, and they were not fertilizing with potassium, and the millet was not performing also as well. But the sorghum has an advantage for those fields that they have low potassium, because the sorghum seems to have a lower requirement of potassium for the forage. So that's why it was not only for the requirement of potassium, they have also more choices to control, the weeds, and that's why they were using some of the sorghums there. So those were kind of the main takeaways there, and there were some other nutrients, phosphorus and sulfur, but the most important was the potassium, especially in this case. All right, well, some of the things that I am seeing is or at least from the tabs that we've seen there, and I comment a bit that some of the genetic improvements are kind of taking longer or not getting to the farmer as fast as in other crops. There is there is a need for understanding that critical level, especially for the nitrogen. So if you can learn from your field what the soil is giving you, you will have a good initial point for you to budget those nitrogen and water. More heads not always means more yield, so there is a range. So obviously you want to have more heads, but there is a point where there is no increase in the yield. And in general, across the agronomic practices, at least that we've seen there, we see that the planting day gets a bit more boost on the yield if you are not already planting early. But there are some conditions where it could be different. Hybrid selection, then the seeding rate, and probably the row spacing was the big question, but we didn't find something very clear to really see, well, so if you say, well, what can I do? Well, I will look first to look at soil temperatures and probably try to plant a bit early if you can. Then probably look if the hybrid for the cycle length that I am looking is fine. And then probably start tuning the population or the row spacing by the end. And for the forage sorghums, well, there was kind of larger nitrogen requirement for the sorghum, but lower for the potassium, which means that if it's a soil that is lower in potassium, the sorghum will have a benefit, or at least in the production of forage in those cases, or need less if you need to fertilize. So some of the future things that I am thinking is that, there could be probably a better collaboration that we can build mostly with seed companies to say, well, maybe throw a bag or two of those new hybrids and do it on farm so farmers can test it in their field. And then we can probably, put it in the on-farm research network so everybody can see it. And that way, it's not a full variety testing, but it can be seen on the field. And then we need to do a better analysis. I think that's something that I am planning to do on more the agronomic components. We see that there is a roof there, 180 bushels for the irrigated. Usually when you look at yield, it's the number of kernels that you have or grains, and then you have the seed weight or the weight of those grains. So it seems that we are needing more grains, but how we can produce those more grains. And then, well, there is more need probably for the understanding of that row spacing, when it will work, when it doesn't work, what are the benefits in general in the system, not only on the yield. And then some macro and micronutrients that probably is a bit outdated for sorghum that we should potentially focus on. So with that, I would like to thank you for listening at that time, and hopefully you got all the numbers there. And yeah, thank you to all the sponsors, Sorghum Checkoff and the Sorghum Board, and then while there are other sponsors for different projects that they were helping with that sorghum research. So thank you so much, and I'm happy to take any question or discuss something. Thank you.